Hello students, so far we have been discussing the main developments of Bohr's atom model. Already we have learned dual nature of radiation and atomic spectra are the two developments of Bohr's atom model. Okay, what is meant by dual nature of electromagnetic radiation? Yes, according to Albert Einstein, electromagnetic radiation behaves like particles as well as waves. Okay, this is called dual nature of electromagnetic radiation. Yes, light is a form of electromagnetic radiation. Then the properties of light like diffraction and interference can be explained using its wave nature. Okay, the properties of light like diffraction and interference can be explained using the wave nature of light. Okay, wave nature of light. And the properties of light like photoelectric effect. Photoelectric effect and black body radiation. Black body radiation can be explained using its particle nature. Okay students, today I am going to explain to you about a very important property of light, that is photoelectric effect. The photoelectric effect was discovered by the famous scientist Heinrich Hertz. Yes, what is meant by photoelectric effect? Okay, yes, this glass tube, evacuated glass tube, and the two ends of the glass tube connected with the two metal plates. One metal plate is connected to the negative end of the battery. This metal plate means which act as cathode is made up of light metals like cesium, potassium, rubidium, and another metal plate, yes, which is connected to positive end of the battery. It is it acts as anode, and it is also called detector. Okay, then a voltmeter also connected here, voltmeter. Okay, then please listen. When light of suitable frequency falls on this light metal, Heinrich Hertz observed diffraction in the voltmeter. Okay, on the basis of this observation, he concluded that flow of electrons, that means electric current, flows through the circuit. Okay, yes, according to Heinrich Hertz, when light of suitable frequency falls on light metals like cesium, potassium, etc., light can eject electron from the metallic surface. Okay, due to its particle nature, due to the particle nature of light, the light ejects electron from this metallic surface. These ejected electrons are called photoelectrons. These ejected electrons are called photoelectrons, and photoelectrons, photo means light. Okay, these photoelectrons move towards the detector, and these electrons flow through the circuit. Okay, then the electricity thus produced is called photoelectricity. What is meant by photoelectric effect? The phenomenon of ejection of electrons. When light of suitable frequency falls on certain metals like cesium, potassium, rubidium, the ejected electrons are called photoelectrons, and electricity thus produced is called photoelectricity. Yes. Then, what are the important observations of photoelectric effect? First observation, Heinrich Hertz observed that for each metal, certain minimum frequency of light is required to eject electrons. This minimum frequency is called threshold frequency. Threshold frequency, its symbol is nu zero. What is meant by threshold frequency? Threshold frequency is the minimum frequency of light required to eject electron from the metallic surface. Okay, the value of threshold frequency is different for different metals. Please listen. The second observation. Okay, when frequency of incident light increases, the kinetic energy of photoelectrons, the speed of photoelectrons increases. That means kinetic energy of photoelectron is directly proportional to frequency of radiation. When frequency of radiation increases, the kinetic energy of photoelectron also increases. Okay. Third observation, the number of photoelectrons ejected per second from the surface of metal depends on intensity of radiation. When intensity of incident radiation increases, the number of photoelectrons ejected per second from the surface of metal also increases. All these observations could not be explained using electromagnetic wave theory of light. Okay, then a new theory of light was developed by Mr. Max Planck. The theory of light is called Planck's quantum theory of radiation. Then these observations, the observations of photoelectric effect, can be explained by Planck's quantum theory of radiation. Very important theory. Okay, in my next video, I will discuss the main postulates of Planck's quantum theory of radiation. Okay, students, goodbye, study well.